Oh, that doesn't look right. That's better. Hi, everyone. Thank you for coming to my talk. Data visualization using Python and Jupyter Notebooks. Let me get a little bit of a feeling for the room. Who here has used Excel before? Raise your hands, please. All right. Keep your hands up, keep your hands up. Who likes using Excel? We got two persons. You do you, I don't. And I don't think I'm alone with that, but there's something much better out there. Now, not to say Excel isn't great, but Jupyter and Python is just better. Now, to me, thank you for the introduction. I'm a software developer at Qvest. I'm usually working on the back end, and sometimes I run around as a consultant asking questions to my customers and getting very interesting answers and trying to make sense of it. And that's what this talk is basically about. Now, I work for Qvest. Qvest is a big group. It has many companies below it. One is Qvest Digital. Qvest Digital does digital product development. So basically, customers come to us and say, hey, we want to build this digital product, and we are the guys that make it happen. And we are also partners with nice guys at eSolutions. And yeah, it's quite a big company, has grown a lot in the last few years, and we are, I know this slide isn't great to read, but it's just advertising anyway. We are all around the world, and we get some really big customers, and so I get to see a lot of cool stuff that I wouldn't have to get to see otherwise. And yeah, so why make this talk? This talk rised out of a need because when I go to a customer, I often find some legacy application or some data set, and it's a mess. It looks like something like this, and I have to make sense of it. I have found over the years that there's a huge ecosystem that the data science guys build that's really, really easy to use. And I'm not a data scientist, so if you are, this talk is probably a little bit too low level for you. But if you aren't, I just want to show you some cool stuff they made and to see how easy it is to use and to gain some cool knowledge about it, stuff you might find when you're at a customer and need to make sense out of, yeah, the digital version of this. Who is this talk for, though? You'll probably need some basic Python knowledge. Not much, though. If you can read pseudocode, you'll be fine, and the rest you can look up. Python is easy enough to learn. And this is for situations where Excel just is not enough. It's either it's too much data, or you need to do too complicated operations, or you want to make some imaging, some visualization that is just annoying to do in Excel. And it's oftentimes you find that the data is just messy, like just importing it into Excel and doing a little select this and making a slide of it just it doesn't work quite well because we need to fix up the data first. I say Excel is bad. Why do you use Python? Well, on the surface, is Python the right tool for this job? You could ask that, isn't that way too slow? And I found this random bioinformatics page that had this benchmark, and it says basically C is fast, Java is also fast, Perl is very slow, but Python isn't not much faster either. And now you're thinking, well, I've got tens of thousands of rows of data. I can't wait all day. Not to worry, though. The data science guys found a great solution. You might also say, doesn't Python have this terrible package management? I mean, there's an XKCD about it. Yeah, it does. There's some workarounds that make it easier, especially in the cloud. We'll be talking a little bit about Google Colab, but not to say Python has great package management, because it just doesn't. But it's well enough, and it has a package for literally everything you can think of, and that's really, really convenient. And lastly, I don't want to set up another thing. If you run around as a consultant a lot, you get to set up for every customer, and your workstation becomes a mess very fast. You have every programming language under the hood, and I don't want to set up another thing. And so this is why I suggest you, if you do this, do it in the cloud and don't make your local setup worse. It also saves a lot of time because you don't have to install packages and figure everything out. It's just there and it just works. So why use Python? And the answer is one word: it's the ecosystem. Python has an amazing ecosystem for doing any kind of data work, and especially on the visualization side. I don't think there's anything that comes close to it for any other tool, any other programming language. At least I haven't seen it. If you have, talk to me afterwards. I'd love to see it. But for all I care, this is awesome. So what do we need? At the foundation of all of this is this fundamental layer. It's NumPy. Now, NumPy basically adds large multidimensional arrays and super complicated high-level functions to Python. And you won't interact with it, but you need it because it's basically a bunch of C code and Python bindings, which makes it really, really fast. Now, with just normal Python, it would be hard to do a lot of data science because it would just be too slow. You'd sit there for days. But with NumPy, you've got bindings to C, and you can basically write Python and execute C code very conveniently. Now, most of the data I get is it's some form of table at the end of the day. And large multi-dimensional arrays sound really cool. I need tables, and that's where pandas comes in, which is an abstraction layer above NumPy, uses NumPy internally, and it adds basically two big data structures. This is the data frame, which we'll be mostly using today, which is just a 2D table with some labels and very convenient ways to interact with it, very convenient ways to mutate it, and to do it very fast with trivial, very Python-esque code. And the 1D version, which are just series of data. Now above that, I've got matplotlib, and this is just one of several libraries that have each thousands upon thousands of visualization templates you can use. If you can think of it, somebody built it using matplotlib or some of the others that I'm going to be showing today. Now about that, there's our user interface, because I don't want to do this in an IDE. That's, in practice, rather inconvenient. And the data science guys, they built something really cool. It's called Jupyter Notebook. Now, if you have never used this before, and I would like to see a show of hands, who has used Jupyter Notebooks before? Okay, so let's say a third of the room. Now, if you haven't, don't worry. It's surprisingly simple. Now let's look at our visualization libraries. What have we got? Now, if you do math and science stuff, you can use matplotlib. It has every possible plot you could want under the sun. Literally thousands of examples on the website. And in my experience, it's a bit finicky to get to look right. It's even harder to make it look nice. But if it's raw scientific data you have, this is probably what you want to use. There is Seaborn, which is like an add-on to matplotlib. And it's in essence, a collection of very nice templates. They look really nice. There are, of course, less options than the basic matplotlib. In my experience, they are very opinionated. And if you don't find the one you need in theirs, it's probably not the right library for you. But it's not all. There's Bokeh, which is my personal favorite. It's awesome. You can make interactive plots with it using 10 or 15 lines of code. And it basically looks nice by default. And it's very easy to use. And you can do very complicated things very easily with it. And Bokeh itself also has thousands of templates, so you'll never run out. And there are even many, many more of that. Down there. There's Plotly, Altea, Plot9, HoloViews, Folium, and probably 20 more I haven't mentioned yet that you could be using. So yeah, I suggest if you ever stumble upon this a problem that you want to use this for, look around a bit. There's probably a library that does exactly what you want already there. Now, if you have never used a Jupyter Notebook before and you think, oh, that's a data science thing, that's probably complicated. It has like 5 buttons. And that makes it really surprisingly simple, but extraordinarily powerful. It's basically a notebook. You can add markdown text above. So this is when you add a text cell, or you can add code cells and execute Python code within that environment. Python is not really a browser language. You can technically cross-compile it, but usually you have some server that does the computation for you, so your browser doesn't get slow. And this is the free version of Google Colab I'm using, which is basically Jupyter Notebook in the cloud, and Google gives you free compute behind it. I think it's like 4 CPUs and 32 gigabytes of RAM for free, and you can do your computation there. And what makes Jupyter so powerful is you can output HTML, and it shows there. Now that seems surprisingly simple, but it allows for so many awesome things, and it makes it very convenient to interact with it. And yeah, there's a play button, means execute this code snippet, and the output is shown below. Anybody that can use Excel can use Jupyter Notebook and probably be fine. Huh? My button doesn't work? No, there we go. So, what do we have to do? If I skip one, no. What do we have to do? So, in order to visualize our data, we have to do 4 very basic steps. We need to load our data into pandas frames somehow. Get to that. Almost always, we need to transform that data into something else. It's either fix it up, get some information from it, like count this row, and then we visualize it, and in the next step, we try to gain some insight of using the visualizations we made. So I talked about pandas data frames. Pandas data frames are essentially tables. And we need to get our data, my experience is usually CSVs, into those data frames somehow. It's easy enough. And then we can use pandas to manipulate our data using this very nice Python-esque syntax. And it's all C bindings, it's all super fast. You don't need to worry about performance in practice. Let's have a look at some basic operations using pandas. Yeah, you just import pandas in Google Colab. It's already there in the environment. You don't need to install anything. Here's some example data. And you just say, pandas, make me a data frame from this example data. We got Alice, Bob, and Charlie, and their age here as an example. We can also just read it from a CSV. And with df-head, we can look at the head of the table we just created and have a look, get a little bit more of an understanding of what the data is. You can tell it to have, to show me the head 10 or the tail 10, show me the top 10 or the bottom 10, and take a look at your data as it is right now. Minor note, if you read it from CSV, your CSV needs to be formatted correctly. So if you have issues with your CSV, my personal workaround is load it into Excel once, export it again, and that usually fixes up most common issues I've seen in generated CSVs to get it to work right into pandas. I'm sure there are workarounds for it. In practice, this is the easiest way to do it. Or fix whoever makes your CSVs to give you correct CSVs. Once we have our data frame, we can do operations for it. We can select single columns from it, just using it like a Python array. We can select multiple columns. It's now looking more and more like a SQL. We can do filters on it based on a condition. For example, you can ask, who are the young people, and give me the data frame, age, and everybody under 30. No, I'm already not in that anymore. And we can add a new column to it. This makes it, yeah, so like right now we got the gender column that we added to it, and it's female, male, male. And you see, this is not really hard. I mean, it sounds like hard data science, but in practice, you look it up, and it's really easy to do whatever you need to do. You can do some grouping of data and do some calculations. In this example, we group by gender and see at the age table and see what's the mean age of that particular gender. And you can do sorting. Well, like we can take a column, sort it by age, do it ascending or descending, and we got a sorted column. This is actually sounds trivial, but it's rather important. Usually, especially when you want to visualize it, you need to fix up your data a little bit. You need to look, are there any missing data? Almost always when you export something, there's something missing. It's never complete. So you can ask, hey, give me the tables where it's null. You can ask pandas to drop those columns in your table, or those, not columns, the lines in your table, where the data isn't available. This is just a good cleanup practice. And you see, it's in place true. It means this operation is done in place, which is really hard to do in Python normally, but because we got C bindings, we can just tell it, hey, do this in place, and it's fast and very memory efficient. Or, and this is what I usually do, is just, well, if there's NA, just fill it with zeros. And I think those are the last two ones that you really need to be kind of aware of. You can apply functions for it. If you're not a Python programmer, this lambda syntax is just, this is a function, and it says x input and return x plus 1. And so we can make everybody a year older. And the last thing is we can merge data frames, which is basically like doing a join in SQL. Can merge data frame 1 and data frame 2 here on some key, and now we got a new data frame that contains all we need in one. Yeah, that's basically what you need to know about pandas, and if you got that down, you can do a whole lot. Now, Bokeh. As I said, my favorite library, and Bokeh integrates really nicely into Jupyter. It's got some integrated functionality, and it speaks pandas natively. So I can give Bokeh, hey, here, take this pandas data frame, make it look nice, visualize it somehow. It looks nice by default. Matplotlib doesn't. Bokeh does. And with just a couple of lines of code, you can also add interactive elements, like have a slider and this changes some value and it gets recalculated and everything. Super convenient, super easy. I won't be getting into too much of the exact syntax here because it's always something you have to look up. You see there are tons of examples on the website. You find something kind of similar and you change it up as you need it. So, a very basic example, how do we do it? Within our Jupyter Notebook, we import the necessary libraries. In this case, it's figures. Figures is the base of a Bokeh plot. Every Bokeh plot is a figure, and you use figures to do something. You need to have the show functionality to integrate it into Jupyter Notebook, and you need to do some setup. On this example, I'm just creating some random values, x and y, some random points on a grid. And we now try to create a plot, which is, yeah, not that hard. We say output notebook. You need to do this if you're in Jupyter Notebook. If you don't, it just creates a HTML file, which is standalone. So once it's created, you don't need your code. You can integrate it into your website if you want to. But if you're in a Jupyter Notebook and you need to work with it, you need to tell it, hey, I'm in a Jupyter Notebook environment, output me this to a notebook. Then we create our figure. I think this is pretty obvious. You got your x label, x-axis, you label it, your y-axis, you label it. you give it a width and a height. It's, from what I've seen, it's always static from the sizes. You can't do scaling, automatic scaling very well, but you can do interactive scaling. So keep that in mind. It's probably not perfect in that regard, but if you just need to gain some knowledge from it, just make it large enough. Yeah, and then we created a few circles within that plot. We give them the x and y, and remember this is not one, this is an array of x's and an array of y's, make them blue, and then we show the plot. And with a few lines of code, we get, yeah, a basic scatter plot. And that's bokeh. Now you see on the right side there are these buttons. This is the default button. You can scroll within it by default, and you can zoom within it by default. You can do selections and so on. You can customize that to a great extent, add new functionality if you want to. Usually it's just fine to leave it as is. Now I want to get into some practical examples, and this is all inspired by stuff I have actually done to protect the innocent and the guilty alike, and in this case it's mostly guilty people. I had to anonymize this a bit or a lot, depending on it. So I know these examples might sound contrived. I will give you the original example that inspired it afterwards to get an idea. So, example 1. You are a multinational company that sells some kind of item all over the world. And you want to make your organization more efficient. You want a new distribution hub, and you need to figure out where. World's big place, where do I need to put my distribution hub? And in order to do this, you need to figure out, hey, well, where are my customers coming from? Now there's some example data on GitHub. It's just some basic CSV examples I'm using. Those were generated. We'll see that later as well. Yeah, we'll see what we can do with this data. So if you download it and put it into a data frame, it looks something like this. You got a table, you got your customer names, and those are all not real names. Don't worry about it. Your city and your country. And the example I chose here has 10,000 lines of code. Execution in Jupyter Notebook takes 1 second. Yeah, you to try that in Excel, and it takes like 10 seconds for the 100,000 example, but that's annoying to download because it's a zip. So let's start first by looking at the top 50 countries from that. And I think I have yeah, I've got a slightly larger version here, so we can try to read it. If you're locally, you probably have to look at the other displays to read it, but I'll go through it on a very high level so you can get it. So we can tell pandas, hey, this is my URL, download this CSV from the internet, do it for me, I don't have to bother with it. And then we look at it, so we want, what do we want to achieve? We want basically a data frame that has the country name and how often this country name is, that do we find in the data, because every time we find it in the data, there's a customer there. So we do a few simple operations with pandas, and now we got a new data frame that has 2 columns. There's the column, and it has the count column. Now, don't worry too much about the syntax. I'll get to that later. And with that, well, we just need to feed that into bokeh. We say, well, I need a new data source. It's a column data source. Look it up. It's like how bokeh does this kind of stuff. And we want the top 50, because in this example, there are like 200 countries or something. And we'll show that. We add some labels to the axis, and down below there, we look at the result, and we try to gain some insight somehow. Yeah, that doesn't help much, right? However, if you think about it for a second, we already learned something, because that's our data source, and this is the result. Below you have a country every time, and we have 2 countries that seem to be much higher than the rest, but everything else seems very unified. Now, in practice, this is highly unlikely, and there are like countries I have never heard of before that have the same amount of customers as, for example, the United States. But you already learned something. And if we zoom in a little closer, we can actually read it. I hope you can read it here, but it's the simple version is Congo and Korea in this probably randomly generated data source have the most customers, and it's uniformly from there. Now, as we saw, this data set is obviously generated, and this is already something we learned. If I gave you just the raw data and told you, hey, this is some data, can you tell me if it's generated or not? You probably couldn't tell that easily. And if you now look at it, yeah, this is very likely generated. And now, I know what some of those countries are, but has anybody here heard of Mayotte or Kiribati as a country? Those were in the top 10. I hadn't heard of them either. We also learned that pandas is pretty fast, ingesting 10,000 columns in this and doing some math on it. Well, takes less than a second in the cloud. But fair enough, you could say, well, I could still have done this in Excel. And it's probably easier to do it because I'm used to it. And I still don't know where to put my distribution hub. So we need a map. Now, we noticed one thing, and that is the data calls Korea, Korea. Now, if there are two Koreas right now, and the map I want to use, which is also from pandas, it has both. And so we need to change the country where every time it says Korea into South Korea, because this is probably what they mean by Korea. And that's something you need to do when you look at data. You need to gain some insight, gain some understanding, and even sometimes change it correctly. Now, it's generated data. They could just as well have meant North Korea, but in practice, they probably meant South Korea. So we do just that. We tell pandas, hey, whenever it says Korea, replace it with South Korea, so it now looks nice on a map. I won't, for time reasons, get into too much how to make this map. You have to look it up anyway. I can never figure this out. It's a bit of a complicated process. It involves some conversions into JSON to make the map look nice. But get to that, ChatGPT can help you there quite well. And then we get a map. And this is a color-coded map. It shows, well, where are our customers located. And yeah, again, it's generated data, so it's a bit more uniform than you would expect from real data. But we can see that Congo and now South Korea has the most customers. And what insights can we gain from that? Well, if you look at Congo, while it has the most customers, it's surrounded by countries that have very little customers. Now this is obvious, but let's say it was not Korea, but Mayotte, and you don't know where it is. If we were to put your distribution hub in South Korea, where you have your most customers, you would probably have to export everything by plane. So it's also probably not the best place to put it. So what insights did we gain? Well, the dataset is still very much obviously just generated and rather, should I say, uniform. Congo has these many customers, but the neighboring countries don't. And South Korea has many customers, but distribution would need to happen by train. So we probably need some further domain knowledge about international distribution to make good decisions. But maybe we can find somebody who has that and show them the data we now visualized in a very convenient format. Next example. So I had to censor this quite a lot because this is real data. I worked at a, no, this is not the next example, sorry, this is the reason why I made this earlier example. So I worked for an ISP, and they were, in Germany, we don't have very good internet, and so we are rebuilding our fiber infrastructure, and they are in a city. They ask people, hey, do you want fiber in your home? We'll have to build it for you. And you get tons and tons of Excel lists from people, and you need to figure out, well, where are those people, and does it fiscally make sense to build your fiber lines there? So I inserted all this Excel data, exported as CSV, inserted it, combined it, and using just a few lines of code, I was able to geocode the information. So I got, this is the address, and give me a GPS location. And in this case using Folium, but I wanted to show you a bokeh example. You can easily place them on a map. And what we learned was, well, there is this northeastern region of this unnamed city where most of our customers are. And if you zoom in a little, which this map allows you to, you can see, well, it's probably really easy because on every street I could just lay a line of fiber and connect. In almost every building there's somebody who wants fiber, so I can connect all the buildings up. Below that we have a small business park. They also want fiber connection. That's also probably fine. And then there's this one guy, and he lives alone on the street, and he's the only one who wants fiber connection there. And at least in the first stage, I don't think this customer is going to get any internet because it wouldn't be, wouldn't make sense to dig up a line just for this one person. But if you just had the raw data, some few Excel files, you wouldn't know. Scenario 2, and I've got some time for it, and I know this sounds a little bit contrived. It's a real problem I face. So let's say you have a customer that had built a very large distributed Visual Basic application. And let's also say this customer put all the application logic into thousands upon thousands of stored procedures in SQL. And let's also say this customer didn't use any foreign keys anywhere in the database and created views for everything. And now they figure out, well, for some unknown reason, this application is now very, very slow to use, and that's the problem. You get asked, well, can you fix that? Well, first I need to understand what this database looks like. Now you get an export of the database, and for time reasons, I'll skip the code, but basically I got not even an export of the data, I just got an export of all the SQL statements. And there's a very nice Python library. This is just an example. I can't show you the original code because it would tell you a little bit which company it was. Basically there are Python libraries, and again, this is the ecosystem part that can parse SQL statements, and you can now build something that looks a little bit like this. Like for every table you got, and for every connection you got, you can have a graph, and you can say, well, maybe those tables are connected, those tables are disconnected, maybe those tables are connected more, others are connected less. And maybe this gives you a first insight on how to fix that. In practice, this involved a lot of, like parsing the SQL was easy, but there was a lot of weird sequences, and you need to filter out views on databases and so on and so forth. And it took a lot of massaging of the data to get some value out of it. And the result was something like this. Every dot is a table. The connections I had to is one SQL statement or one stored procedure that connects those tables. And if you make the tables, the connections thicker for every connection, you can't see anything. But the bigger the table, the bigger the dot, the more often this was used. And with a little of trial and error, you can see this was probably the users, and this was their product, which they sold. And all of that around it was connected by it. Now we can zoom in a little, and this was done using bokeh as well. And yeah. Okay, so using no foreign keys and only stored procedures is probably not good software architecture. I wouldn't recommend it. But the point I want to make is the Python ecosystem has a parser for literally anything you can think of. You don't need to write your own parser to get your data into pandas. I could just insert a Python, it was Python SQL parse in this case, and parse some random SQL stored procedures, and I didn't have to do any work, which is always nice. And yeah, sometimes you really, really need to rewrite your software from scratch. And lastly, that plot really looked cool. I mean, I like this. I couldn't help them because it was like, yeah, well, you did this, I can fix it. But it looked really cool. So in conclusion, Jupyter Notebooks are really, really easy to use. They got 5 buttons. You can figure this out. You can handle literally millions of data sets in seconds. And the only thing you really need to do is get your data into a pandas data frame, massage it a little, and if you need to visualize it, Python got you covered. Now, lastly, ChatGPT was written by data scientists for data scientists, and it's really good at this stuff. So don't even bother reading the documentation. Generally ask ChatGPT first, and you'll get there much faster than trying to figure out, especially bokeh or matplotlib. Just tell ChatGPT, I want this done in matplotlib in Jupyter Notebook, and it's probably going to get there really, really fast. Now, ending in time. Thank you for listening to me. I hope you liked it, and I'm open for questions.
Thank you very much, Thomas. And I'm as well curious, what are the questions going to be?
Hello, thank you for the presentation. I'm Marius from GameLabs here. I'm wondering, when you do the visualizations, especially the interactive ones in Jupyter Hub, do you have like a mechanism to deploy them somewhere for business users who don't use Jupyter Hub, sort of like building a dashboard and putting it somewhere?
So there are some great tools to do that. Let me get to the beginning. I think it's called, there's so many of them here. This Plotly, I think it's called, and it's made by a company that basically does exactly that. Plotly itself is just another one of many of these visualization libraries, but these Dash guys basically allow you to integrate those into dashboards so you can deploy them somewhere. That's really convenient. For my use cases, it was usually more of a, here's the stuff, figure out, and then talk to the business guys or the domain experts, okay, what does that mean, and what information can we gain from that?
Okay, so more like exploratory data analysis.
Yeah.
Yeah, okay, got it, thank you.
Do we have another question? If you are keeping your questions for the coffee break, then I would love to ask you if you have encountered anything that you could tell us as a downside of using Python in the combination that you just presented.
Yeah, so, and this is maybe the great upside of Excel. You don't get anything to enter your data, or at least not easily. Your data is expected to come from somewhere, and then you read it into Pandas data frame. And if you just have it in Excel, you can work on your data directly, insert a function here, and so on. So yeah, entering data into this is really annoying. If you do it by hand, you probably want to source the data from somewhere.
Thank you very much, Thomas, for your honesty. And thank you for your presentation.